Hello students, welcome to the Easy Learn channel. So today we are going to discuss about the homologous series, the continuation part of the carbohydrates components chapter. Definition says that a series in which compounds with the same general formula but different molecular occur in immediate succession. It says that the series in which having the compound having the same general formula but different molecular formula. See, by giving the example, you might have going to know the definition of this clearly. Have a look towards the alkane. Okay, what is the functional what is the formula of the alkane? CnH2n plus 2. Okay, so for this formula I am going to substitute n is equals to 1. I am going to get, if I substitute n is equals to 1, I will get C1H4. See, that is what I wrote here. And if I substitute n is equals to 2, I am going to get C2H6. In n is equals to 3, C3H8. Just substitute yourself and then confirm for yourself. If you do, then only you are going to give a perfectness. Next, if n is equals to 3, C4H8. N is equals to 4, 5, C5H12. For your sake, I am going to show this. N is equals to 5. If I put n is equals to 5 in this case, C5H, this one is there, right? 2 in n place 5 plus 2, I am going to get. So C5H, 2 5s are 10, 10 plus 2, 12. See, C5H12. C5H12, same like this. If 6, C6H14 we are going to get. So what is the main thing I am going to say here in the sense? See, if you see the difference between this and each and every one, the difference we are going to see is CH2. In each and every CH2 is the difference. That is which says the immediate succession. So one by one, only the difference of CH2 only this is going to occur. And just remember here, the meth, eth, prop, but, penta and the hexa. So in all indicates that this is the single bond. Okay, single bond. Here meth indicates only one carbon. Eth indicates 2 carbon. Prop indicates 3 carbon. But indicates 4 carbon. Penta indicates 5 carbon. Hexa indicates 6 carbon. This list goes on increases. This is for the alkane, A-N-E, alkane, that is a single bond. Okay. Next, have a look towards the same thing, alkene formula CnH2n. Okay. And here n is equals to 2. In the case of the here we started n is equals to 1. But in the case of the here we can't start n is equals to 1. Why? Because alkene in the sense that is a double bond. Only one carbon can't get the double bond, isn't it? So we require starting from the 2 carbon. That's why n is equals to 2. If we substitute n is equals to 2 in this formula, I am going to get C2H4. If I substitute n is equals to 3 in this formula, I am going to get C3H6. For your sake, I am going to show this n is equals to 4. I am going to get C4H8. Just have a look. For this formula, I am going to substitute n is equals to 4 here. That is a C4 and H in the n place 4 I am going to write. So what I am going to get C4H8. See, in the n is equals to 4 in this formula if we substitute C4H8 I am going to get here. Okay, in the same like this. And just observe here, alkene in the sense that is a double bond, and always you remember it. Prop, but, pent, hexa always represents the number of the carbon which is present here, and the ene, all ene is there. This represents the double bond here. Okay, on the next one. This one will be the alkyne, the last one, what we are going to call it as. The formula we have, that is a CnH2n minus 2. This one also shows for us that is n is equals to start with the 2. If we put n is equals to 2, we used to get C2H2, 3 this one, 4 this one, 5 this one. For your sake, I am going to show the 5 for you. C5H, see in this n place, I am going to put a 5 here. 5 minus 2. C5H, 5 2 ja 10, 10 minus 2, 8. See, 5 8. See this here also we have the difference is CH2 only. CH2 only. Here also we have the difference. And in the case of the here we also have CH2 from here to here, from here to here, from here to here. See, in the all the cases we have only CH2. That what we used to mention it as a immediate succession. It's a compulsory for you to remember the homologous series formula, and along with that how actually it is going to occur one by one. And we have some property for this also. That is the first one. They have same general formula. As you already know that alkene, alkene and alkyne has a same general formula, isn't it? Fine. The gradually increases of boiling and the melting point from the up to down, of course. See, have a look here. Here CH4 is a small one which we can break down with the supply of the little bit amount of the heat. But when come to the C2H6, the amount of the molecule is more. To break this, we have to supply the more. That's why when we go down, what happens? The amount of the gradually increases the boiling and the melting point here, and the atomic mass also increasing from up to down, of course. When the this one atomic size increases, atomic mass is also going to increase there. And the member of the same halogen series have the same chemical and the physical property. Yeah, see, this is how we are going to call it as a same halogen series. So this one has the same physical and the chemical formula. This one also has same chemical and the physical formula. This is how all about the homologous series. I hope I made you clear. Thank you.